let's take what we know about absolute value problems and apply it to what we know about inequality problems. So this says the absolute value of m plus 2 is less than 11. With absolute value equations, we know that there are two answers. There's a positive answer and there's a negative answer that we have to find. And with inequalities, it's the same thing. We write them a little bit differently though. Our first solution is going to be we find m plus 2 less than 11, just like we would with an equation. The second one though is what happens if the contents of the absolute value is negative, meaning negative m plus 2 is less than 11. And that's the one that's a little bit different. So these are the two solutions that we're going to find. And this is an absolute value problem where these are separated by and that's important for us to know because we're going to be looking for the intersection of these two solutions. So m plus 2 is less than 11 and negative m plus 2 is less than 11. Okay, so let's go ahead and solve the right one first because this one's the easiest. Let's go ahead and get the easiest one out of the way. We just use the subtraction property to subtract 2 on both sides, and we get m is less than 9. Easy. Over on the right side, one option that we have is that we could use the distributive property. We could distribute the negative to the m and the plus 2. Certainly nothing wrong with that. But the fastest way to get to the answer is to actually start off by dividing both sides by -1. And the reason this is the fastest is because distributing a negative sign like that means there's actually, this is like -1 times m, -1 times 2. So we're distributing a -1. By dividing both sides by -1, we actually cancel these -1s, leaving us with just m plus 2. This makes the other side a -11. Now you may be thinking to yourself, well, this is exactly like inequalities, where we did first one it was positive 11 and the other was -11. Why didn't you just do that from the beginning, positive 11 and -11, like we did with inequality, or like we did with equal signs? And the reason is that because since we just divided both sides by a negative, our inequality now flips. M plus 2 is greater than -11. So that's the important difference with inequalities, is that if this had been an equation, if we'd had the absolute value of m plus 2 equals 11, the two equations we would have solved would have been m plus 2 equals 11 and m plus 2 equals -11. That's how we would have gotten our two answers. With this inequality, the two that we actually get are m plus 2 is less than 11 and m plus 2 is greater than -11. So we don't just do positive and -11, we do less than positive 11 and greater than -11. When we change the sign to be a negative to get our negative answer, we also flip the inequality symbol. Okay, so just keep that in mind when you're solving these. Okay, so we'll subtract 2 on both sides. That's going to give us m is greater than -13. Now remember, this was an and problem. So we're looking for where m is less than 9 and where m is also greater than -13. So all of the numbers that are bigger than -13 and less than -9. So when I do my, I don't know why I said less than -9, just less than 9. So I'm going to go from -14, -13, -12, -11, and so on. 5, 4, 3, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not going to number all of these because it's such a wide. Did I miss some? 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, -1, -2. I think I did miss some. -10, -9. You know what? It doesn't matter. You get the idea. My number line's off by a little bit, but I'm not redoing it. You get the idea. My number line needs to show everything that's bigger than -13 and lower than 9. So because these are both less than, greater than, and do not have the equal to lines on them, that means I'm going to have open circles. So open circle on -13, open circle on 9, and I want to include all of the numbers less than -9 and greater than -13. So all of the things, let's do a thick line here, all of the things in between these two. So there we go. Everything greater than -13 and less than -9. And again, please do not count the actual lines on my number line because I messed it up, but you get the idea. Doesn't have to be a perfect number line. Anything bigger than -13 and less than 9, that's my inequality. Any of those numbers in between there will work in the inequality. So like if I pick a random number in the middle, let's say -3, for example. Let's use -3 since that's in there. The absolute value of -3 plus 2 is less than 11 will give me a true statement. -3 plus 2 is -1. The absolute value of -1 is 1, and 1 is, in fact, less than 11. So any number I pick in that range is going to give me a true statement for my inequality, which is why they are all solutions.